includes
Nesse vídeo, você vai aprender.
Introduction and the course. First, let's discuss about the course. What is this particular course? In Master in DevOps course, we will describe the complete life cycle of the DevOps. We will see the combination of the technologies, how they can use individually and how they can use combinedly to achieve the complete DevOps life cycle. This course is very helpful for those people who are beginner in the DevOps, who are going to switch into the DevOps, and who are working as a DevOps engineer in multinational organization and want to learn some new technologies, some good features of the DevOps. If you have a question, why should I enroll in Master in DevOps course? Then the answer is, this course is not related or not limited to a single technology. Here we are going to describe thorough knowledge of the DevOps with Git, Jenkins, AWS Jenkins pipeline, Docker, Docker Swarm, Docker Compose, Docker Machine, Kubernetes, Kubernetes administration, HAM, and Kubernetes cluster deployment in high availability zone. So this course is combination of the technologies. We are refreshing the content of the course periodically. As soon as new technologies, new versions are coming in the tools, we are refreshing the content accordingly. So welcome team, I am Anshul Chauhan. I am professional cloud developer, have working experience more than 8 years in multinational organization as a DevOps engineer. Currently, I have the expertise in DevOps, cloud technologies, cloud development, and enterprise application development. I've also worked as an automation engineer and automated the complete products which have the engineer base more than 600. What technologies are part of this Master DevOps course? As I told you earlier, we are going to learn a bunch of technologies in this particular course. We will see the complete knowledge of Git, Jenkins, Docker, and Kubernetes. First, we will start with the version control system Git and GitHub. We will see the basic to advanced in Git and GitHub, how we can integrate the Git with GitHub, and how Git is helpful in version control system, and why we need version control system in our organization. Then we will move to the continuous integration. We will see after the product development why Jenkins is required, what is the continuous integration, and how the continuous integration will be helpful to gain the true agile in your product lifecycle. In the continuous integration, we will develop the fully functional continuous integration and continuous delivery pipeline with the help of the Jenkins. I will show you how you can set up your own Jenkins server with fully functional CI/CD pipeline. We will also work with the hottest DevOps technologies like Docker, Docker containers, Docker images and networking, Docker Compose, and Docker Swarm orchestration system. We will start with the basic and reach the advanced level inside the Dockers. We will see what is the Docker, what is the need of the Docker, how Dockers are different from the VMs, what is a Docker container, how we can manage the data inside the Docker container, how we can create the persistent Docker containers, how we can create our own custom image, what should be the part of that particular image, how we can tag these image, how we can download and use these image, what is the concept of code reusability inside the image. We will also jump into the Docker networking, what is the egress, what is ingress, how bridge and default networks work inside the Docker. Then we will move to the Docker Composer and Docker Machine. We will see how Docker Composer and Docker Machine provide the complete orchestration on developers' computer machine for the Docker. And in last, we will see the Docker Swarm as an orchestration system. How multi-container application can be bind into a single application with the help of the Docker Swarm. How you can enable the networking between the Docker Swarm. How you can set up the network bridge, the services, and connectivity between multiple containers. So these are few topics which we are going to learn inside the Docker part. These are going to be very basic to high-end technology lectures. In the row of the Docker, we will learn few more technologies like Kubernetes, Kubernetes cluster administration, deploy and maintain application on the Kubernetes, HAM package chart managers. Inside the Kubernetes, we will again work with the basic so that the newcomer, the beginners can also learn these technologies. We will see how we can set up the Kubernetes on local machine, on AWS, on GCP. What is the Kubernetes? How Kubernetes is helpful? How we can create the cluster of the Kubernetes? How we can manage the Kubernetes so that other people in our organization can also use the Kubernetes? How we can scale down the application without zero downtime, how we can upgrade the application without the zero downtime, what is the blue green upgrade, what is the zero downtime upgrade, how we can package the application for the Kubernetes, how we can create the pods, containers, Kubernetes networking, Kubernetes deployment, replica set, services, how we can create the load balancer, how we can create the internal load balancer. There are going to be multiple things which we are going to learn in this particular Kubernetes course, right? So these are the technologies which we are going to cover in this particular Master in DevOps course. Altogether, this course is going to be 45 to 50 hours long. So if you are planning to learn this particular course, then please make sure this course is going to be a bit lengthy, but this will provide you complete knowledge of the DevOps. After this particular course, you will get your own certification that you have completed this particular course. During the course, we will provide some assignment, we will provide the exercises, all the required PDFs, the commands which we are using in this particular course during the development of this course. These commands and these slides will be attached as a PDF in the lecture resource, right? About what is DevOps and what are the DevOps tool sets. So we are going to cover these few topics in this particular lecture. We will learn why do we following the DevOps practices, right? And what is the benefit of the DevOps practices. So first, we will learn about the evolution of software development over the years. Then we will discuss a use case history of Facebook which uses DevOps. Then we will learn what is DevOps, and at the end we will learn about the different tool sets which is used for the DevOps. So let's start with. So in the previous time, or you can say in the earlier time when software development started, there was different kind of models, right? There was different kind of software development life cycles. So the most popular software development life cycle was traditional waterfall model. In the waterfall model, first we gather the requirement in the planning phase, then we do the coding, then we do the testing, then maintenance, right? So this is the complete product life cycle of the traditional waterfall model. So every phase have their own significance, right? So in the planning, we was basically gathering the requirements. After then we will start the development, and after the development we test the complete product, and after the test we deploy the complete product and we use the maintenance, right? So there was a different kind of gaps available in that particular waterfall model, as the product release life cycle is very long, right? Because we can't release the product until we built it completely. The testing effort is huge, the development effort is also huge, because we are developing the complete product and after then we are starting the testing, right? We are not doing things in the parallel. So that model have these loopholes. So the next model which comes in the market is agile development. In the agile development, the product developed in feature wise, the agile is basically feature wise development. In the product we develop a single feature, right? We take the requirement, develop the feature, test it, and again go to the development if we are getting some kind of bugs. Once we complete single feature, we pick up the second feature, right? So in the agile development we have a very short time deliveries, right? Requirements in the agile model, requirements changes very frequently, development needs to be fast. But after the agile, now we are working in the era which is called DevOps approaches. So DevOps approaches is best suited when we have the requirements changes frequently, development needs to be agile, and operations also needs to be agile. In the DevOps era, the development and testing will continue in a single phase, right? We can develop and test the product in parallel. Let's see how we can do that. So before move to the DevOps and DevOps technologies, first I would like to share experience of Facebook, which Facebook experienced in 2011, right? So we know very well Facebook is a very big company. They hire the best engineers from the market, right? They are also working on cutting edge technologies, and Facebook is example of the best engineering in the world. So Facebook launched few features in 2011. In 2011, Facebook introduced new features like timeline, music, and ticker, right? So in the last diagram, you can see where we have the word map. So we are showing over here the different data centers of the Facebook, right? These are the deployment zones of the Facebook. So when Facebook basically released these features in 2011, they deployed the new features on their all data centers. They basically released the new features worldwide in a single go, right? After this, they faced some challenges. So basically, at the time of 2011, Facebook have 500 million users worldwide, right? They released some new interesting features in their website which attract a heavy traffic on the Facebook servers, and in result, Facebook servers melt down. They stopped working, right? And when the servers stopped working, there was the delay in the Facebook, there was the delay in the Facebook opening, there was different kind of issues user experienced. So they got the mixed response from the user, which leads no conclusion, because there is no way to remove these features, there is no way to come out from these kind of situations, right? So after this, Facebook created a strategy which they called the dark launching technique, right? So after this incident, Facebook comes with the dark launching technique. So let's discuss what is the dark launching technique, what is the strategy Facebook maintains after the incident of 2011. So according to dark launching technique, they basically divided the dark launching technique in three parts. In the first part, they discussed and they implemented a way like new features are first deployed on a smaller and specific user base. So instead of the complete user base, first, if we are introducing a new feature in our application, if we are going to deliver something new, then we will open that particular feature for a specific group or for a smaller group, which Google also used in the Google Chat. First, Google Chat was introduced in the company itself. Google Chat was open for the Google employees only, right? So the new feature will first deploy on a smaller area or on a smaller zone, right? And it will be open for the specific user base, right? Then they continuously monitor the feedbacks and continuously develop and test it. So basically, here we are getting three new terms. First is the continuous monitoring, second is continuous development, and third is continuous testing. These three terms are basically comes in the DevOps. So when we are basically deploying a basic feature or a new feature to a specific group, we are monitoring the feedback of that particular feature. We are continuously developing the bugs, okay, which we are getting in that particular feature, and test it and again deploy it, right? So there's a cycle. We will discuss about it, this particular cycle, with a very good diagram in the coming slide, right? Once the feature is stable, once we know that that particular feature is stable, right, they are deployed on other user bases in multiple releases. So after the feature is stable, we are still not going to deploy the complete feature over all data centers or overall or complete application. We will release it in multiple release for a specific users. Suppose first we will release it for the Asia, then we will release it for Europe, then we will release it for America, then we will release it for UK, right? So we will release the new features in chunks in multiple releases. So this is called the dark launching technique. So this is the diagram of the dark launching technique. So very first, the Facebook is a company which introduced a new feature, right? It will deploy it on a specific user group, which is in the yellow belt, right? And a specific data center. Then we get the bugs, so we roll back the feature. So basically over here we can see a cycle is being generated. First, the feature is going to a specific user. We are getting the feedback, which is called continuous monitoring. If we get some kind of feedback, some bugs, then the feature again go back to the development team, right? they will fix it and test it. This is called continuous deployment, development, and continuous testing. So feature is being released to a specific group. They are being monitored. If we are getting some bugs, they again go to the development team. Development team fix and release a new build. It will again test it and again go to the development team if there is a bug. So there is a complete cycle which is called continuous monitoring, continuous development, and continuous testing. Right? Once we have the feature stable, right, we will release that particular feature to our other users. This is called continuous integration, right? Once we have that particular feature in our application, we will open that feature in multiple releases to multiple users. This is called continuous deployment. So we are deploying our application continuously on different data centers or different data zones. So here we learn 5 new things, right? So this is basically the implementation of the dark launching technique are the activities or the fundamentals of the DevOps lifecycle. And DevOps lifecycle is all about the continuous deployment, continuous development, continuous testing, continuous integration, and continuous monitoring. Right? So this is the phase which started the DevOps. Now we learn about the DevOps. So as we have already discussed, DevOps is not a technology. DevOps is not any programming language. So basically DevOps is a software development approach, right? Right waterfall model, right agile model. DevOps is also a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of software throughout its development lifecycle. So it includes the plan, code, build, test, and after the test, deploy it, operate it, and monitor it. If we are facing an issue, then again go to the plan, code, build, test, and again deploy it, operate it, and monitor it. This is a complete never-ending cycle, so that we have a sign like this, which is infinity sign of the DevOps. So we are basically working in releases. We are planning something, coding that particular thing, developing that particular thing, build the project, test it, again deploy it, right? After the deployment, we will operate it, monitor it. If we are getting any issues, we are getting any feedback, we again go to the development phase. So this is never ending cycle, but in the DevOps, we have a very frequent releases. If you have, if you want, you can release your software weekly, bi-weekly, twice a month, thrice a month, or in 2 months, in 3 months. So basically in the DevOps we have a very frequent releases. This is the benefit of the DevOps approach. In this particular diagram, we are displaying some kind of tool sets which is required for the DevOps. So when we are talking about the plan and code, we can use some tool sets like Git, right? Like Subversion and Jira. Jira is used for the defect reporting. Git is used for the uh, software version controls, and so Subversion is also used for the software version control. We will discuss about the Git, the complete Git tutorials in the coming videos. Then we will build our project. We have the different kind of build tools available in the market like Maven, Ant, and Gradle. We'll use Maven in this particular tutorial, right? We will learn about the Maven. If I will get the time, I will create the lectures on the Gradle as well. Then next phase comes with the test, and we have the testing tools like Selenium, JUnit, Rest Assured, right? So here you can see we have different phase, and we have different tools available for each phase, right? Then we have the continuous deployment and monitoring. For that we have the tools like Ansible, Puppet, Chef, SaltStack, right? Then we have a continuous monitoring, and we have New Relic, Sensu, and Nagios. This complete phase is basically called the DevOps phase, and these are the tools of the DevOps profile or DevOps approaches, right? So we are building the project, we are developing the project, we are building the project, we are testing it, we are deploying it, right? Monitoring it, and again building it. So this is the DevOps, the continuous development. So let's start with. So we have already discussed the DevOps part. So DevOps is basically a software development approach which involves the continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. And these phases will be followed throughout the development lifecycle.
right? So the very first phase of the DevOps is about the continuous development. So we are going to discuss about the continuous development in this particular lecture. We have already discussed about this diagram, right? So the complete DevOps phase is basically divided in 7 stages: the plan, coding, build, and test. After the test, we integrate our tested code with our existing code and deploy it on our either the testing server or on production server. After this, we will operate that code, monitor that code, and again it's come to the bug fixes in the development. So this is the flow, the tools what we are using from the DevOps point of view. In the development, we are using the Git and Subversion, right? We are also using Jira as a bug tracking tool. So basically these are the 5 stages of the DevOps lifecycle. Very first stage is about the continuous development. The second is continuous testing. The third stage is continuous integration. Fourth one is continuous deployment. And fifth one is continuous monitoring. In this particular tutorials, we are going to discuss each and every phase in details. First, we will start with the continuous development. To understand the continuous development in detailed way, I have divided these particular DevOps lifecycle phases in the tasks. So planning and coding is the part of continuous development, right? Build and test is the part of continuous testing. After the test, we will integrate the tested build with the existing code. It's called continuous integration, and deployment and operating part comes in the continuous deployment, and monitoring part comes in the continuous monitoring. After the monitoring, we find some bugs and it again goes to the continuous development. So this is an infinite loop where we are building a product and we are incorporating new features in every sprint. So we will discuss about the continuous development in details. So what is continuous development? So continuous development is a phase which involves the planning and coding of the software application functionality. You remember we have already discussed the waterfall model. In the waterfall model, there was the drawbacks like first we need to plan, then we need to code, then we need to test, then we need to maintain the code, right? Over there we have a lot of kind of documentation like we need to done the SRS, we need to done the complete requirement gathering, but this is not true with the continuous deployment, but this is not true with the DevOps phases. Here we divided the complete product in small chunks and we will deliver the product feature wise. We are not delivering the complete product in a single release, right? So we have the planning, and we call these planning as a sprint planning, and a sprint have 2 weeks or 3 weeks duration. So basically we are delivering a part of feature or a complete feature in DevOps lifecycle in a single sprint or in a 2 sprints. So you have the very frequent releases when you are basically working with the DevOps phases. Either you have a single release every month, or you have weekly release as well. So the planning and coding is comes into the continuous development phase. We will in the sprint planning, we will plan what work we need to do in that particular sprint, and in the sprint we will do that, right? The version of the product is decided during the planning phase. So when we are basically releasing the product, so we are releasing the product in small releases. So we need to define a version of every release. Suppose you are going to release your product first time in a market, then your release will be 1.0. But after a month, you are going to release a new feature in your product, then that release would be 1.1. The next release would be 1.2, and the next release would be 1.3, and so on, right? Code can be done in any language. It is the decision of your organization, it is the decision of your development teams, right? So we are not going to done or we are not going to decide that thing, that which language, which programming language we are going to use, because a single application can use multiple programming languages, right? It is not straight away that a single application can only use the Java or only use the PHP, right? A single application can use multiple languages for multiple tasks. But we need to maintain that code with the help of the version control system. So we will version our code which we are releasing in every sprint, right? So we will discuss about the version control system in the coming slides. Now, first we will discuss why code versioning is important. So versions are maintained to hold a single source of application. When we are doing the versions, so basically we are merging our code in our integration branch, or you can say in our application code. So suppose let's take a scenario, you are not versioning your code, right? You are just created 1.0 branch on your version control system, right? And you are pushing every code in that particular branch, right? And one day you got to know that 3 days before or 4 days before we pushed some incorrect code in our production, right? So how can you roll back that particular code? So if you are using the version control system and you are versioning your code, then you need to know that which version of the build was working fine, which version of the build don't have that particular issue. So you simply roll back your code to the previous version, right? Using the centralized single source code, operations can be accessed the same code what they plan to release. So with the help of the version control system, we can use centralized code repository, right? And operations can access the same code what they plan to release, right? This is very simple. Easy to roll out the faulty snippet of the code and complete release. So if we are using versions, so as we have discussed, we simply can roll out the faulty code or we simply can roll out the complete release in an easy way. So where DevOps comes into the picture? So in the continuous development, DevOps comes into the picture when we are talking about the versioning of our code, right? The tool which we are going to use, or the we can say the most popular tool of the version control system, is Git and GitHub. So Git is a tool and GitHub is a repository. So we are going to use Git and GitHub as a version control system. The very second section of this particular course will describe all things from A to Z about the Git and GitHub. So this is the simplest diagram where I have described the distributed version control system. So on our server, we have a single repository where all my code is placed, right? Then we have the second layer of repository. This is called staging area. So when we will learn about the Git, we will learn about all these things. The second phase is called the staging area, and the third, which is a working copy on your desktop. So basically you have a working copy of the code on your desktop. You are committing your changes, or you are doing your changes, or you are pushing your changes on the staging area, and from that staging area the code are being pushed to the central repository. So this is called the distributed version control system. You can see we have the single source code in every machine of my organization, in every machine of my developer, right? So if anyone lose the code, in that case, if you lose your single repository, then you can simply push the complete code to the server. So you don't have any loss in terms of the code. We will discuss about all these things in the coming lectures when we will learn about the Git. So this is the distributed version control system where the same source of files are distributed across the systems of developers. So from the DevOps point of view, first we will learn about the Git and GitHub. That's all for this particular lecture. If you have any question related to this particular lecture, then you can ask your questions in the question and answer forum, right? Testing is the second phase of DevOps product lifecycle. As we have already categorized the phases into the DevOps phases, right? Continuous testing covers two phases of the product development lifecycle. The first is product build and second is product test, right? So when developer have completed their code, they check in their code to the repository. Either they will check in their code to some specific branch, or they will check in their code to the integration or master branch. From that particular branch, we will build our application, and after the successful build, we will execute some kind of verification and validation test to qualify that particular build. So this is called the continuous testing. Let's discuss it in details. So basically, let's take an example. You are working on a product and there are close to 40 to 50 developers in your team. They have decided some kind of work in the starting of sprint, right? Every day they are doing some kind of development work and they are checking in their code to the central repository, right? Now, the policy of the product build depends on the organization or on your management. Either they can build your application every day or they can build your application after every particular time duration, like after 6 hours, after 8 hours, or in a day. So suppose we are taking an example, you are building your product in once in a day. So in the daytime, in the working hours, developer done their job, they check in their code. After their code check in, you are building your product, right? Once the product build will be ready, you are executing, or your Jenkins server, the continuous integration server, is executing some kind of verification and validation test on that particular build. They tests are fully automated, either with the help of the Selenium for the UI or with the help of the rest assured for the backend testing, and they are qualifying their build, right? They are qualifying your product application build. If the test pass, then you are saying our build has no defect, right? If your tests are basically failing, then you can say the latest code is breaking the previously existing code at that particular point of time. So you can easily find out the bugs, right? What is the benefit of this particular approach? So today you have done some kind of work, but that work is basically breaking the previous code, right? Your new code is breaking the existing code. With the help of the continuous testing, we can verify that particular gap. If we are not following the continuous testing model, then today your build is green. It doesn't mean that your build is qualified from the QA, right? Because your today work is done, you have implemented the complete feature in the current sprint, but you have already breaked something which was done earlier. With the help of the continuous testing, we can fill out this particular gap and we will immediately know the developer that particular code which you done in that particular time frame is breaking that particular code which is done previously. So developer can proactively work on it and fix it. So this is the benefit of the continuous testing, and this particular process is called continuous testing. In the coming lecture, we will discuss about the continuous integration. That's all for the day. Hello team, welcome back. Welcome to the Jenkins for the DevOps training. In this particular lecture, we will learn about the continuous integration. So we will learn these few topics in this particular course. Very first, we will start with the continuous integration. In short, we will call it CI. So we will learn what is CI. Then we will move to the challenges if we are not using the CI process in our software development lifecycle. After then, we will learn about the continuous integration tie-up with the continuous delivery and continuous deployment. We will also see why we use Jenkins for the continuous integration. So let's start with the continuous integration. So basically, continuous integration is a process of automated builds and automated test. When we are saying the automated builds and automated test, let's understand this particular statement. So suppose our dev team and our QA team is working on an application and we have a 10 or 15 developers in that particular team. All the developers are checking in their code in some kind of shared repository, right? So Jenkins or the continuous integration is something like to pull the code from that particular shared repository and build it with the help of build tool, whatever is being used in the development. Either it could be Gradle, it could be Maven or Ant, right? And after the build successful, execute the test on that particular build. So this is continuous integration. Also, the automated test is not a part of the continuous integration. Continuous integration is limited up to automated build, but to extend the continuous integration process, we can include the automated test in the continuous integration. Continuous integration helps us to detect the error quickly and locate them more easily. Yes, definitely it's a very true statement, because suppose you are working or you are building your project with the help of the continuous integration in every 2 hours. And suppose you have built your project at 4 p.m. today, and again it will build at 6 p.m. today. And in the 4 p.m. build, everything was working and everything was fine, and at the 6 p.m. build you get some error. So you need to look out the changes, the commits which will be done between the 4 p.m. and the 6 p.m. so that you can easily locate the errors and resolve them. So continuous integration help us to find the errors quickly and locate them. So basically, as we discussed, continuous integration is not about to resolve the bug. It's all about to find the bug more quickly in your build pipeline or in your automated build. Let's start and discuss about the challenges which any software organization will face if they are not using the continuous integration. So this is the diagram which explain the issues, the problems if you are not using the continuous integration. So the first set is all about the developers. So the developers are basically doing the frequent changes in the source code repository, right? And after these changes, after some particular period of time, these changes will be picked and they will be merged to the master branch of your project, right? And your project will be built every night, or you can say once in a week, with the master branch. And once you will build your project, you will get a lot of defects, right? Sometimes there could be the compilation error, sometimes there could be the genuine product failures or product defects. So you need to notify to developers like these are the defects which we are getting. But this complete process took 1 to 2 days, because suppose in the today morning developers check in their code, in the evening you will merge their own branches with the master branch or with the integration branch. Next day you executed your build life, your automated build. Your build took around 4 to 6 hours to execute, and after that you will get the result. So the complete process is a very time taking, and it is difficult to manage that particular process, right? It will also impact your releases, because it is putting a significant delay in your release process. So this is the problem if we are not using the continuous integration. The developers are being informed about the bug lately. They are not getting the complete, they are not getting the on time report of the bugs. Source code, the merge of the developer's source code with the integration branch may basically release the compile time errors or merge conflicts, right? It is impacting the release life cycle, and it is putting a significant delay in your product release. So this is the issue which company was facing if we are not using the continuous integration. Now, if we are using the continuous integration, then our process would be like this. A set of developers are doing their changes in the source code repository, and that source code repository is basically handled by our Jenkins server or the continuous integration server. In the continuous integration server, we are building the product, we are executing the test on that particular product and deploying that particular build in our test environment or production for the further use, right? So since every commit to the source code is an auto build is triggered and then automatically deploy on the test server. So there could be option in the Jenkins when you want to trigger your build. If you want, you can trigger your build on every commit. If you want, you can schedule your build, like your build will be scheduled uh, and every hour or every 2 hours or at particular day or at particular time of a particular day, right? So suppose you have scheduled your build process in every 3 hours. So now you know that your build execute at 6 a.m., then 9 a.m., then 12 a.m., then 3 p.m., then 6 p.m., right? So suppose your build executed 6 a.m. in the morning, right? After the 6 a.m., your next build will execute at 9 a.m. in the morning. So at the 6 a.m., the build was successful. All test cases, the smoke and sanity was done, and the build was deployed on the QA environment for the integration testing or system testing. But at 9 a.m., when the build process again execute, you got some error in the compilation, right? So you need to know, now you know very well, like all the commits which is being done from 6 to 9 have some kind of issues, or a single commit which is done from 6 to 9 have some issues. So you can easily find out the culprit code change or the issue in your code, right? So this is the process of the CI, and it will help you to improve your complete build life cycle. It will make your release very fast. So let's understand the benefits of the CI. So continuous integration brings multiple benefits to your organization. Basically, we don't need to wait for the long and tense integration. All the integration is being picked automatically and it will be merged to my master or integration branch. Increase visibility, enabling greater communication. So basically, we are building our project more frequently, so we are getting the results more frequently. If we are getting some gaps, then we can communicate to the developers or the respective teams on a significant amount of time. We can catch the issues in the earlier stage, although if we are not using the CI server, it may be possible we will catch the issue in the production. We need to spend a very less time on debugging, and we can use that particular time to build new features in our application. We don't need to wait that our code will work on the production or not, our code will work on the Q environment or not. You can get the results, you can get the updates in very few hours. It will also reduce the integration problems, allowing you to deliver the software more rapidly. So basically, if you're using the continuous integration, we can uh, release the source code frequently, we can release the application more frequently. Now let's discuss about the continuous deployment. So continuous deployment is related to the continuous integration and refers to keep your application deployable at any point of time. So with the help of the continuous integration, we are building our project, and with the help of the continuous deployment, we are building that image or we are building that application. Let's discuss about the continuous deployment. So continuous deployment is related to continuous integration and refers to keep your application deployable at any point of time. So what does it mean? So with the help of the continuous integration, we have created a build of our application, right? With the help of the continuous deployment, we are basically deploying that build on our QA servers, on our staging servers, or on our production servers, right? So as soon as your build will be ready, with the help of the continuous deployment, you can deploy that particular build on your QA environment for the build qualification against the integration test, regression test, sanity test, and system test, right? And if all done, you can deploy the same build on the production. So with the help of the continuous integration, we are building our project more frequently, and with the help of the continuous deployment, we are deploying our fully qualified build on the QA environments or on the production. With the help of the continuous deployment, you can deploy the application latest version on test and production environment, right? Now we will discuss about the continuous delivery. So continuous delivery is a practice of keeping your code base deployable at any point of time. Beyond making sure your application passes automated tests, it has to have all the configuration necessary to push into the production. So when we are talking the continuous delivery, then we have a handy set of latest builds and we can push any build anytime in our production, right? So continuous delivery is basically being enabled. If your continuous integration, your continuous deployment will be successful, then definitely your continuous delivery will be successful. If you failed in the continuous integration, then you will fail in the continuous deployment, and you will again fail in the continuous delivery. Because if the product build is not a successful build, is not a qualified build, then you can't deploy that part. Fourth and fifth phase, which is continuous deployment and continuous monitoring. So first we will start with the continuous deployment. Continuous deployment is basically the combination of two parts. First is the configuration management and second is the containerization. Before discuss about the configuration management and containerization, first understand the continuous deployment in layman terms. When we are saying the continuous deployment, then we are talking to deploy our service across all the servers which are running. Either it could be the cloud machines or the hosted machines. When we are releasing our application on servers, then basically this is called the application deployment. So continuous deployment will take care your application deployment on all your servers. The servers could be the QA environment, they could be the performance environment, they could be the production, or they could be something else like testing environments or some other environments, right? So continuous deployment will be responsible to deploy your fully qualified application on the production or performance or any other environment which is intended. Again, continuous deployment is a part of configuration management and containerization. First, we will discuss about configuration management. Configuration management is all about to maintain the configuration of your servers which will be compatible to your application requirement. So configuration management is basically, we can understand the configuration management with these four bullet points. First one is to establish and maintain application functional requirement and performance. So basically on our all servers where my application is being deployed, I will configure these servers so that they server will basically justify or they will fulfill my application's functional requirement plus performance requirement, so that the minimum configuration which is required to set up my application will be done with the help of the configuration management, right? The second phase about the releasing deployments to the server. So basically, we will release the same deployment across all the servers. This is the work of the configuration management. If you are going to release your product 1.8 release, then 1.8 should be released on all the servers. They could be in the phases or they could be in a single go. Second one is about scheduling updates on all servers. It means if you have something to update on the servers, if you have some kind of security patches, some kind of image changes, some kind of operating system upgrade, some kind of some related service upgrade, then that should be done upgrade on all the servers. This is the job of configuration management. And the last thing which we will take care in the configuration management is about the configuration consistency. It means all the servers, all the hosted machine where my application is being deployed or is going to be deployed should all have the same configuration. They should all have the same operating system, same kind of RAM, same kind of resources in terms of the hard disk, same kind of resources in kind of any programming languages version, same kind of resources in kind of any tools, right? The second part of the continuous deployment is about containerization. Containerization is basically a set of tools which will maintain the consistency across the environment. So basically, with the help of the containerization, we will packet all the dependencies of my project in a single container, right? And we will deploy the same container across all the servers on my on which my application is going to execute, right? So let's understand it with the simple example. You have some kind of application which is required Java 8, which requires Gradle 1.3, which requires some other third party jars, suppose the rest assured jar 3.6, and you can say the caching server Redis server 6.3, the analytics server stack Sparks cluster 6.1. They require some authentication service 4.0. So containerization is something in which we will kept all the tools which is required to run my application in a single container, and we will deploy that particular container on all my servers. This is called the containerization. So don't worry about these things if you are not able to relate these things right now. When we will go through the Docker part, you will understand all these things. So Docker is the first containerization tool in the market, right? Scheduling update on all the server is also the part of containerization, which means if suppose in my release 2.6 I have updated my authentication service from 4.3 to 4.4, then all the containers which is running on all the servers should be updated with the authentication server 4.4 version, right? Maintain configuration consistency across all the server is the part of the containerization. Now we will discuss about continuous monitoring. Continuous monitoring is the monitor of the system performance. It is all about monitoring your server, monitoring your application from the performance point of view. So suppose your application is being deployed on a machine which have the configuration like 32-bit GB RAM and 8 core CPU and 500 GB hard disk. Your application definitely are producing some kind of logs which is being stored on the hard disk. Your application have some kind of RAM requirement. Suppose your application is running on 8 GB Java heap and your application is being configured to uh, execute a load of 10 million transactions in a particular time frame, right? And you are getting more than that particular transaction on your application, so definitely it will decrease the performance of your application. And suppose your log files are basically generating too frequently and you are not rotating them, then it will basically fill up your hard disk very rapidly, and you have some kind of memory leakage issue in your application, then it will crash your RAM. So basically continuous monitoring have some kind of tools like Dynatrace, Nagios, which will continuously monitor your application as well as your server health check. What kind of memory is being used, what kind of operating system is being used, what amount of CPU is being used by your application, what kind of RAM is being used by your application, right? So these all things are basically comes into the continuous monitoring. In the continuous monitoring, we will monitor the product overall performance at different stages, right? This is the very critical phase of the product life cycle. That's all about the continuous deployment and continuous monitoring. So we have discussed all the things about the continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. In the coming lectures, we will learn about the Git, then we will move to Maven, then about the build tool, then we will move to the Jenkins integration server, and in last, we will learn about the Docker. So thank you guys. I hope you like the video.